All righty. I hope everybody had a good weekend, and I hope everybody took the test, which only 7 or 8 of y'all took it, but the class average on those 7 or 8 was like 92 or 89 or 92. I can't remember which one it was. So everybody's doing good on that. So let's go ahead and get started on the new chapter. I think we go into chapter 5. Check your syllabus or your outline. I think we go into chapter 5. Chapter 5 is probability. I do not like this presentation system. Let's see. Let's get rid of that. And also, let me bring it up. And what is probability? Go ahead and turn the front light off if you don't mind. Some of you, okay, I'm going to do that. I don't think I'm going to be able to write on the slideshow, so we'll have to go to another screen. Sorry. Let me go to probability. I'll give you a Hubertism definition. Assigning a number value to a prediction based on observation, experiment, or statistics. That's basically what probability is. Now, of course, the reason I throw statistics in there is because that's most of the time about 80% of your probability is based on statistics. The other 20% is based on observation and experiment, which also leads to statistics, but sometimes people do things different. Most of you are familiar with 2-lane highways. Now, there's one 2-lane highway in Anderson that I'm very familiar with because I used to travel it every single morning before I started working at the extension campus. The Anderson campus. And that is Wild Hog Road. Okay? If you're not from around here, or not from around here, Wild Hog Road is also called Highway 187, but there's 2 Highway 187. There's one south of 24, which goes down to Sadler's Creek, and then there's one north of 24, which goes to Pendleton. But most people around here call it Wild Hog Road. Anyway, get on that road, and it takes about 15 minutes to get from the Bilo Double Bridges area takes about 15, 16 minutes to get from Bilo. I know some of y'all can travel in 1 minute. You ever notice that? Whenever you talk about traveling, there's always one guy in the group. You notice it's a guy, always a guy, that can travel it in the speed of light. You ever notice that? Girls, walk away, get away. Because that's the type of person that'll put smokestacks on a pickup truck. Okay? They got some overcompensation issues going on. Okay? Get away from that person as fast as you can. They're just like guys, the girls that Oompa Loompas, the orange face and white neck. Run away from those too. They're the same type people. They're crazy. All right. Anyway, so it takes about, for the normal, non-traveling the speed of light person, it takes about 16 minutes to get up there. Okay? So you get on Wild Hog Road at exactly 15 till. You got an 8 o'clock class or a 20 till. And you got an 8 o'clock class. So you're running it kind of close. So here you are, and you just turned on to Wild Hog Road, and guess who just turned in front of you? The little blue-haired old ladies club. And the little blue-haired old ladies club, they travel exactly 32 miles per hour. And she's got to go to penalty. So guess what? You're stuck behind her all the way to the end of Wild Hog Road. So you got Pendleton High School right here. My cousin's house is right here. And then you got this this intersection right here, and this is basically Clemson Boulevard, Highway 76, whatever you want to call it. And there's a turning lane right here. You can get in this lane and go to the left, and you get in this lane and go to the right. You get between Pendleton High School and Clemson Boulevard, which is about a quarter to half a mile. And you get up to about 200 feet before you get to the turning signal, before you turn on the turn signal. And you look at her turn signals and you say to yourself, I bet you $1 she's going to turn left. And just as soon as you say that, what happens? She turns on her turn signal to turn left. Wow, you can tell the future. No, you just put a number value, the dollar, on a prediction. How did you know that prediction? You never got behind that one old lady. But you have gotten, see, they have a club. And they used to use CDs, but now they use cell phones. And they make sure they clutter up every 2-lane highway in Anderson County. Okay, they communicate. So you may have gotten behind one of her cohorts, but you have taken that data and you have run it through your brain, even though you're not a mathematical person, you've done it. And you've run it through your brain and you can predict what's going to happen. Now, there's another explanation. Anybody that's taking Wild Hog Road isn't going to Sandy Springs. That's another explanation. Usually a person traveling from 24 to Wild Hog Road, 90% of the time, they're going to be going to what? Pendleton. So that's another thing that's in your favor. All right? Because if they were going to Sandy Springs, they could have cut off at the doghouse, not the doghouse, but cut off at, and I can't think of the name of it, but it goes to Sandy Springs right there. I can't think of the name of it. But anyway, comes out right there. But he also could have turned behind Pendleton High School and went back that way. You could go 2 different ways to Sandy Springs. But that's how you can tell the future. So basically, you are a, what do you call it? A fortune teller. So you should get on TV, like Miss, what's her name, Cleo, and tell people their future. Because you were able to predict the future down here. Why did I say that sarcastically? Because no one can tell the what? Nobody can tell the future. Nobody. If you ever meet somebody that says they can tell the future, all you got to do is ask them one question. What's that question? Anybody want to take a guess at it? What's the lottery numbers? That's all you want. I'll give you $50, ma'am, if you can tell me the lottery numbers. But you got to pay me back the lottery number. You got to pay me back the $50 if you're wrong. Give them here. Let's go. Here's your $50. What will that person do? Oh, yeah. I don't do that. I just read off of vibes and I read off of aura. Shut the hell up. Okay? Because you are a con artist. All right? Nobody can tell the future. Now, I will exclude getting hit by divine intervention, meaning by lightning. Okay? And by divine intervention, whoever your divine interventor is, that divine interventor puts it in you. Yes, that could happen. But unless you get hit by lightning and start telling the future, I'm not going to believe it. There's nobody that can tell the future. Because you would be in Vegas if you could tell the future. Don't sit there and lie and say, well, I would be helping people, I would be royalty. Shut up. You would be in Vegas right after you hit the dadgum mini mark down here, minute mark. After you won a couple of thousand, 100,000, and then you get the plane ticket to Vegas, and then after you win 3 or 4 million through lottery tickets and race horses and all this other stuff, after you put all that money in the bank, then you might try to George Clooney the world, okay? But right now, you just settle for a couple of thousand. But it's not going to happen because you can't tell the future. It's kind of like the old saying, what would happen if you go into the past? There's 2 theories if you could go into the past. What's those theories? Anybody know? Nothing's there. Okay, you ever seen the Langoliers? Y'all ever watch movies besides stupid Transformer movies? Stephen King? Huh? It is a good movie. It is a very good movie. But it goes along the lines of you go back into the future, nobody's there. The Langoliers. Oh, it's a good movie. If you're into time movies, I love time movies. And then there's the movie called The Time Machine, where the guy goes back in time to try to save his fiancée, and every time he tries, she gets hit by another bus. Okay? Not by another bus, by another carriage of horses or whatever. So there's 2 theories. One is that you could change there's nobody there, and the egg salad sandwiches are stale. And the other theory is that if you did change the future, the future will still happen some other way. Okay, so that's, and with same thing with predicting the future. If you could predict the future, you would not be sitting in this room this morning. Okay, you would be, and you wouldn't be out trying to tell people what they should do with their lives. That's a farce, right? So what do? We take all the statistics we can take and all the observations that we can, following the Little Blue-Haired Ladies Club, and we say, bam, that's going to happen. I'll show you another example. Now, some of y'all have no idea what I'm talking about here, but I'll go ahead and entertain you with it. There's this, on the farm, there's several things that you may not be aware of. One is the holding pen, and it's got a little pen back here, and you get cows and you run them through a chute, and you put them in the head gate and vaccinate. This is a holding pen, I'd say 100 feet by 100 feet. Now, to get the cows in the holding pen, you got 2 or 3 pastures. And let's say you got a pasture here, pasture here. You don't have one big pasture because you can't get cows up if you have one big pasture. You're running cows all day. So you got 5 or 6 pastures around this holding pen, and each pasture goes to the holding pen, some way, some form with a gate. And all these pastures have gates. Take my handy dandy blue marker and put gates. Got a gate here. Got a gate here, got a gate here, here, and all of them link some way, some form to the holding pen. Well, there's one pasture that touches basically all of them and goes to the holding pen. That would be this pasture. All right, and you get all the cows, you get them in the pasture, And before you do that, you accidentally, let me put a gate up here. But this gate is just there for, I don't know what it's there for. But you forget to close that gate. And we'll erase. And you leave that gate open. Okay, and the gate right here to the holding pen is open. Because that's where you're trying to get the cows. You're trying to get the cows in the holding pen. So and that gate's open. And you're running the cows in from these two gates right here. So you're running, here's all the cows. I'll just put big dots. There's the cows, and you're running them into this direction. And you got about 50, 100 cows. And they're in here, they're moving in. Okay? You got the dogs and the four-wheelers, and you're running them in. And you're running them in. And there's one cow, it's a dominant cow, just like the leader of the pack, wolves. There's one cow out front. I'm back here, and I just see in the corner of my eye that gate up there is open. Where do you think those cows are going to head? Straight for the gate that's open, right here. Not this one. Oh, heck no. They're not going to go to that one. They're going to go to this one. Again, I'm a fortune teller. I should be on TV. No. I have been getting up cows since I was 6, 7 years old. And I can tell you that if there's two gates open, and if you want them to go in gate A, 99% of the time, those cows are going to go to gate B. Okay? You can do this all day long with different type of applications, whether it's the little old lady or whether it's cows in a holding pen. You can predict based on mathematics, observations, experience, experiments. All right? But you put a number value on that experiment or that prediction, I'm sorry. And that number value is going to be from 0 to 1. From 0 to 1, this is your scale. So if you're not familiar with this, you need to write it down. 0.5 is in the middle, of course. And then you just do a number line. And you can break it down to however how many points you want to break it down to, that's fine. But everything in probability is done by a decimal, or equal to 1 or 100 or whatever the case may be. Now, with probability, you know you got your math geeks and you got your statistics geeks. There's two different people, okay? Probability and statistic geeks, they're crazy, all right? They live, eat, and drink statistics and probability, and that's all they talk about, all right? If I spelled that right. They speak in terms of decimals because that's their language. If you walk up to a statistician or a probability guru and you say, well, I bet there's a 95% chance that I'm going to win that money on that lottery, they'll probably have a heart attack because they do not speak in terms of percentages. They speak in terms of decimals. Okay? It's kind of like the teacher going crazy if you say ain't in English. Even though ain't, after hundreds and hundreds of years of speaking Southern, the word ain't has finally become a word. Some English teachers want to fight the system and say, oh, well, ain't's not a word, you're not supposed to use it. Well, it is a word and people use it, so deal with it. Okay? But they cringe when you say the word ain't. Well, probability nuts, they cringe when you say 95% chance. All right? That's usually when you're talking about odds. Usually, odds are when you're talking about chance, which you're talking about percentages. So Is it a big deal? No. Is it going to stop the earth from revolving? No. But if you ever are working in the future, when you get your degree and your family and your career and all that, hopefully your career comes first. When you get into a job and you have a department head or a division chair, or you have a boss or a director or whatever, and they're a statistician nut, just deal with it. Just, even though you're used to dealing in percentages, just change everything to decimals. Because chances are they're going to have a conniption if you say 95%. But most people are pretty normal, and if you come up to me and say, well, that probability is 95%, I know you mean 0.95. And I'm not going to have a cow, but some people will. And you just need to make a note of that. Now, remember that everything on this scale from 0 to 1, this makes up the whole area. Now, whole is a pretty strong word, because there's two things that make up a whole. Black, white. True, false. 0, 1. Guilty, not guilty. Okay? What are those called? In other words, there's two parts. You name one part, the other part is called the what? The complement. One part plus the complement. I think it's a complement. I have a hard time spelling it. I want to spell it with an I, but I think it's a complement with an E. The complement is what makes up the whole. So if you're talking about 0.35 probability, the 0.35 complement would be what? 0.65. The complement of 110 students, or 100 students, if you have 50 students that are blind, the other is the complement would be 50. Whatever makes up the whole, whether the whole is n as a population, or whether whole is a probability. If I say there's a 0.75 probability that this person is not guilty, you say there's 0.25 probability that they are. Now, the complement can work both ways. Like I said, it can work as a probability, or it can work as a population in a classroom. Okay? So, for instance, if I say 0.75 is blue, then you can say there's 0.25 not blue, or red, or whatever the case may be. The complement, if I state 0.75, you state the complement by saying 0.25. If I state 100 students are in the class and 50 have blonde hair, then you tell me that the complement is 50 that what? That do not have blonde hair. And usually in statistics, in probability, the complement is usually got an X through it, or doesn't have an X through it, depending on what is stated first. Yes, ma'am. They've already figured it for you. Well, the probability is already figured. Over here, you would say, well, let's change this to 65 is blonde, therefore 35 is what? Not blonde. So you would say the probability of being blonde is 0.65, and the probability of being not blonde is what? 0.35. Here you have to calculate the probability. No, it can be easy. Okay? Yeah, I just use 100 because it's mathematically easy. Okay? It could be 556. 500 people are educated, 56 are not educated. Whatever the case may be. The complement is what makes up the whole. Okay? So you're going to see this a good bit in this section, in this chapter. There's 3 chapters. There's 3 sections that I go over. This is by the old book. I I don't even have one of these books, so you have to find these sections, and I'll tell you what they are. The first one, I can get another page, please. The first section is called the additive law. Oh no, it's not called the additive law. Okay, now we got red. We don't have an eraser anymore. That changed. First one is called probability. The second one is called the additive law. The third is called the multiplicative law. And the fourth is called counting. So I need somebody that has an idea of what's going on, meaning the person that has an outline or a person that has rather an outline. Tell me where you see these four things so I can write them up on the board so everybody, especially the non-coherent people, will know what sections we're going to be covering for this test. Okay? So somebody looked that up on their outline. Did I give you an outline? I think I emailed you an outline, didn't I? Gives you just 4 units, like on a chart. See if I got one of those handy. Okay. Well, just look for it and tell me what it looks like, and we'll go ahead and start with the probability, and I'll give you these sections. These are the only 4. This is going to be an easy test. It's going to be a quick test. Probably in the next week, not this week. God, these hands are going to go crazy. Probably sometime next week or the next, okay? So it's going to be real quick. Not as long as the first one, because we had to go through a lot of stuff in that chapter 3. Did you find your outline? No, that's those objectives. Those things are worthless. Oh, that's my handout. No, that's not it. Does anybody have it? I thought I sent it to you. I know I did.
Would it be?
It's a spreadsheet chart, and it's got Unit 1, Unit 2, Unit 3, Unit 4. Okay, well, I guess I didn't send it because I'll tell you why I didn't send it. It used to come behind your syllabus. Okay, it used to be the last page of your syllabus. Everything was in there in the syllabus. And then some brilliant person said, let's separate it and put the syllabus here and put the outline on Blackboard. Which is about the dumbest thing I think I've ever heard of. Doesn't make any sense what some of these people make up. I don't understand it. So now instead of going to one place and getting both things, you have to go to 2 places. Don't even get me started. But anyway, I'll get you those sections later, or look in your book. All you gotta do is look in your table of contents and find these sections. All right, probability. Probability of an event happening. That's the way it's written. The probability of an event. It could be the probability of blue marbles, and you would put probability, parentheses, blue marbles, or BM, or blue, or whatever you want to, is equal to the number of times something happens over the number of times something is tried. Now, in the first chapter, or the first unit, which is mainly chapter 3, you had to calculate, you had to do math, okay? And you had to read the problem. In this section, you have to read the problem even more, because the problem is going to tell you what you have to use, not just calculating. It's going to have to tell you what to use. It's one of those things where there's a difference between the word or and and. If you see the word and in the last part of your problem, you use this method. You see the word or in your problem, you use this method. So, and there's 2 types of probability. I call the Mayberry probability, which is called the, I don't know what it's called in the book, because they change it every few ticks, so I don't know what it's called. I guess you'd call it theoretical. And I don't even know if I spelled that right. It don't look right. Theoretical. Is that right? Some of you spelling gurus tell me if that's right or not. It looks right. No. We'll need to look at it. Theoretical probability means mathematical. Okay, good. Thank you. Where'd you find it? In the book or? You need to go to Blackboard because that way it'll be more confusing. All right, which one's probability? Yeah. 5.1. 5.2. And then it skips a couple of stations and goes to counting. All right, there's your test right there. 4 sections on the Unit 2 test. There they are. So that's what you're responsible for. I don't give a rat's rear end what the syllabus says. I don't care what the Unit 1 test, which covers Chapter 1, 2, and 3. My Unit 2 test will cover this. If we have another section that I'm supposed to go over, then I'll make it on the Unit 2A test or something. This is what I'm going to cover right now. Yes, ma'am. And if I cover it, you do it. If I don't cover it, you what? Don't do it. Okay? All right. So the mathematical probability or the perfect probability. Because what was Mayberry? It was a perfect town. Why? No crime rate. Nobody being disrespectful. It was the perfect utopia. So that's why I call it the Mayberry probability. And if you don't know who a Mayberry is, it's your parents' fault. Okay? All right. What does that mean? That means that if I want a king out of a deck of cards, then what's my probability going to be? 4 out of 52. Well, how did you do that? You don't have a deck of cards with you. How do you know that? You don't have a deck of cards with you. It's always the same because there's 52 cards in the deck of cards. 54 if you count the big Mo and little Mo, or the big Joker and little Joker. But the whole point is, nobody's going to change that deck of cards. How about the probability of rolling a 6 on a die? 1 out of 6. Nobody has a die in here. How did you do that probability? Because you know that there's a 6-sided figure called a cube, and it's got 1, 2, 3, 4, 5, 6 dots on it, each side. And if you roll it, there's a 1 out of 6 chance that you're going to roll a 6. And that's called the theoretical probability, or the perfect probability, or the Mayberry probability. The mathematical probability. I don't know why they just don't call it the mathematical probability, but who knows. Now, what happens if you don't know that there's 52 cards in the deck of cards besides being sheltered? No, I'm just kidding. How do you know that? Well, that's the things you have to know. All right? So if you don't know about a deck of cards, you need to go to Walgreens down here and buy you a deck of cards and look at it. All right? Or you can just look up deck of card Bible. Okay? Look that up, Google that, and then it'll tell you about the Soldier's Bible, deck of cards, something like that. And it'll tell you all about the deck of cards in a few paragraphs. Everything about the deck of cards you need to know about. Okay? Now, what's the other probability? What I call the real world probability. The real world probability is what you actually try. Or you actually have a number of attempts. Or you're actually given the data. Okay? In other words, tell you what I'll do. Let me go to my office right quick. Y'all quit sneezing and being sick. That's all. Huh? Be right back. I'm going to get something. You don't can actually have some fun with someone instead of listening to me talk. Now, before I do this, I want to go over something called free time and bonuses and classroom activities. Okay? Usually, they're a little bit more fun than doing what we're doing right now. But what's the rule that I always tell you to remember? There's always what? One person that's going to what? Screw it up. Don't be that person, because you're going to stab everybody else in the back. Okay, everybody understand that? Back left-hand corner? Because y'all are really treading on it. Okay? I've got 1, 2, 3, 4, 5 decks of cards. So that means you've got 20 people in here. So that means 30 people. So 7 to a plus, we have to break up one group. Sorry, guys. All right, and guys cannot be in charge of the cards. All the females of each group, we pick one female in each group to be in charge of the cards and the die and writing stuff down. Okay? Guys are not in charge of anything. We used to have parties the last day of class, and the guys would pretty much screw over the class by not bringing plates and forks and stuff. So from then on, I decided that guys, for those that are listening, are not responsible for what? Anything. So, okay, I got 5 of each. So, I'm going to break y'all up into groups. This is not going to be a group either, because I got to use y'all to kind of keep things in order, okay? Because there's guys everywhere else. Sorry, guys. I can use some of these people too. They're quiet. As we go back to the back of the room, it gets kind of iffy. All right. So I need 4. I need 4 in the back. I need you to disperse. I need one guy up here, one guy over here, one guy back there, and one guy over here. All right. Now, I'm going to let y'all be in charge of it. So let these 5 people be in charge of these. And pick out some people over here. I'm just picking out people, so if I pick you out, there's something I like you or I don't like you. Just don't do anything cause problems in the class. Okay? Alright, so I want you to break into no. Here. Okay. Alright, so take these 5 decks of cards over here with the 5 die. Find a place to sit. Do that right quick, or stand over there for a minute. I usually don't have to do this, but in some classes I do have to. Okay? Come on over here. Come on over here. All right, who's got die over here? Okay, go stand with the dies. Come on, raise your hand high, people. Down the back, he's standing back there, don't have a clue. Stand back. Come on, put him up. There you go. All right. Okay. Now, you two, go over here with this group. You two, go with this group. You two, go over here with this group. Yeah, this group right here. I'm just breaking y'all up. You two, go over here. And you, this is these two. You, come back here. And I need one more person to do me a favor. You, come back here with this. Okay, now, you're going to have one person to record, one person in charge, one female in charge of recording, one female in charge of rolling the dice, and one female in charge of you have to double up. I don't want any males in charge of anything because y'all screw it up. All right? So, I want you to run 20 trials of each. 20 trials with the cards. Now, if the guys want to shuffle, they can shuffle. Let the guys shuffle if they want to shuffle. So they got to show their testosterone somewhere, okay? So, go ahead and do 25 of the cards and 25 of the die. Now, each group, to make it diverse, pick what you want to find the probability of. If you want to find the probability of an even number, drawing one card, then shuffling, drawing another card, then back in, all that good stuff. You want to find the probability of a queen, probability of a heart, probability of a six. Pick one of each. So each group pick a number and just roll one die. We're not going to roll two. Just roll one. Okay? Make it easy. I want you to pick a probability for the die and pick a probability for the card. One probability for each. And then I want you to roll 25 times, write down the data, and I want you to shuffle and pick one card 25 times and see what the results are. So ahead. No, take the jokers out. Make sure you take the jokers out. 52 cards. Take the jokers out. Yeah, it's up to y'all.
And then you pull out a card and you write down whether or not we got it.
Yeah, you write down each card you get, and then you put it back in the deck, shuffle it, and pick again. Put it back in the deck, shuffle, pick again. Put it back in the deck, shuffle. You got to do it 25 times for each. And just use one die in 52 cards.